Yes, good evening, class. Uh, I hope you've gone home. I'm still here. I promised to do a video of two videos, one on rivers. This would link up to our visit to the pond, and the second on rites of passage. So I hope you did enjoy the trip to the pond. I wish we had gone in small groups. I would have organized the class in small groups, but then I would need to attend to all the groups. So I would probably have needed like two TAs, two teaching assistants, to give them the same material, take them around the pond, give them the same material, uh, and then break up the class in groups. But generally, I hope you did get the point about the social construction of nature, of reality, of the environment, and that Salisbury Pond is a reality, right? It's a material object that exists in time and space. It exists in time. The waters have been there since 1827 when the pond was constructed, and it exists in space. You can get the longitude and the latitude of the place and actually pinpoint it that it exists here, right? But it's not the way God made it. It's been constructed, started from an idea, innovative idea, you know. So we got First Nations peoples that were living there, the Nipmuc First Nations peoples that were living there. They were carrying out their subsistence livelihoods, fishing, taking the animals there to drink. I don't know if they had cattle or what, sheep or what, taking them to drink, and also getting the water for drinking. Maybe they farmed nearby. I don't know. I've not checked. It's hard to get much literature on what they were doing, because the next civilization that came, kind of, you could put in quotes that it cancelled that former civilization, you know. And we did say the other day that what we call nature, a place that is untouched by human beings, a place that is non-human, that is untouched by human beings, you know, not made by humans or untouched. And we say that almost most things that we find on Earth have been modified one way or the other by human settlement, by human civilization since the beginning of time. There have been many civilizations. If you go into human history, early human history, there have been many humans that have gone through many different landscapes and transformed those landscapes, not negatively, because human landscapes, the landscapes that we see, we could say they're human landscapes. They were also transformed positively in some cases. Like if you look at indigenous peoples, they had a reverent attitude towards the landscape. You know, they saw the landscape as sacred. They saw spirits as living in rivers, as living in rocks, as living in places, and they worshiped these spirits. They had laws governing their usage of water, the way they interacted with water, the way they interacted with space. And so we could say that their interventions were limited to subsistence, hunting, and agriculture. And even so, they had rules that governed this and made it subsist. But once industrial agriculture came in, you know, in where we have technology and agriculture for profit making, everything changed dramatically. Everything changed. So we get the creation of these ponds for irrigation, the creation of ponds for energy, the creation of ponds to create in order to dam. They create ponds in order to the dam rivers create ponds in order to improve on water flow in canals, to make canals to flow more fluidly so that boats could sail up and down with goods, The rivers needed a certain, like small rivers that need a certain volume of water for boats to carry goods up and down. They have to dam a river, create a pond, and then so that they regulate the water flow in the canal. Maybe the pond would rise to a certain level, right? And then a certain amount of water has to go down the canal. A certain amount of water has to go to enable boats to sail down and up the canal. So there's been a lot of human interventions, and the settlers, they had uh, they had these ponds almost everywhere across the landscape in the U.S. because they needed to generate energy. They needed to generate transport systems to transport their goods up and down. There were no trains at the time. There were no cars at the time. Transportation was only overland with horses or cattle or by water, and water was the fastest means. And so they had to create a lot of ponds, a lot of dams, and they had to channel a lot of rivers, you know. So, so there's been a lot of social construction in the landscape. Now we saw those huge stones around the pond. Those trees were also planted, indigenous trees. The sedge trees, the cattails, those cattails, those sedge trees, they were also planted to filter the waters. So they made the pond to mimic an actual pond, a natural pond. So over a long period of time, because of the trees, the ecosystem that they generated around the pond looks very natural now. Very few visitors that come there know that pond aren't. Very few visitors that come there know that pond was created. It's man-made. It's a man-made pond, but it looks very, very natural now, with the sedges around, with the birds. There are turtles. There are turtles in that pond. There's fish in the Australian carp, which came from Indian pond. It invaded that pond, and it's still there. They are very, very big fish, quite big, quite big. Indian carp. If you go there frequently, you're going to see people fishing, and they catch the Indian carp. They release them. Some take them home. Though they might have mercury and phosphorus. So that is what we call the social construction of the environment. Humans socially constructed the environment in order to suit their anthropogenic aims, their anthropogenic purposes, whether it's subsistence livelihoods, whether it's industrial agriculture, whether it's recreation, energy, transportation, all of that. Much of the mini landscapes were actually transformed. Okay, now when we go to rivers now, the transformation of rivers in the U.S. has been too extensive. If we look at the transformation of the Mississippi River, which is like up till the coming of railway lines in the U.S., before railway lines were firmly established in the U.S., and then road transport systems, and then cars, and then public transportation, it was the Mississippi River, because through the Mississippi River, you could transport goods as far as from Iowa right down to Louisiana. That's a very, very long distance from the north of the U.S., the border with Canada, right down to Florida, right down to Louisiana, the Gulf Coast, for ships to take them abroad. So a lot of goods went by water. Okay, and there was a lot of interventions. You look at irrigation farms along the Mississippi from Iowa right down. The Mississippi was the breadbasket of the U.S. So there's a lot of irrigation. A lot of the indigenous forests along the Mississippi, they were cut down for logging. The logs were floated downriver, to industrial cities, the next industrial cities. Most of those industrial cities, you look at the homes that we live in here, most of the homes are made of board, right? So a lot of those woods along the Mississippi, they were used for boarding, they were used for construction. The Mississippi led to the rise of cities, many cities along the river, big cities in the U.S., in the Midwest, and in the South. The Mississippi was a huge factor of contribution. How did that transform the landscape in terms of sediments? Sediment is very important when we talk of environmental flows. environmental flows. Now we're talking of freshwater flows and environmental flows. Sediments were very, very important. Sediments can be positive and also negative. You know, when they cut down trees along the banks of the river, when they farm along the banks of the river, dig irrigation channels to pump water out on the farm on the both sides of the river, the adjacent terrain. We call that the adjacent terrain. It creates sediments. Those sediments, the river carries down those sediments, and those sediments become a problem because sometimes they have to dispose of those sediments on bends. You know, and when they dispose of sediments on bends, or something holds the sediments keep piling, the river has to change the course when the sediments gets high. And then when the river keeps changing its course because of sediments resulting from agriculture, that creates problems for navigating down the river. That creates problems for navigation. That creates problems for flooding, which means if a river changes its course due to sediments, people who were not impacted by that river, they get impacted. And then we talk of societies now, with settlers moving to the US, the land was parceled out. And parceling out land, it was almost in like, if you look like a checkerboard, like a chessboard, the land was parceled out like a chessboard. So you might have a piece of land which is a distance away from the Mississippi, but because of sediments, the Mississippi changes its course and it affects your land. And people did not want that. That created a lot of problems along the Mississippi. So now a problem, and then floods, when you talk of sediments, when they build up, floods also become possible. So now what happened was they started channeling the river. And channeling the river means they build levees along the river and dikes for irrigation and levees. Levees are raised platforms made of stone, very, very high. Some as high as, like, you're coming up the Salisbury pond. You see that mound there, some as high as that mound, and they go long. They build them along rivers so that when it floods, the river should not affect fields, it should not affect homes. So those levees became very, very prominent along the Mississippi. And those levees are also dangerous because when the river overflows and breaks those walls called levees, and then any farm and any settlements beyond those levees, outside of those levees, the powerful force of the river impacts on houses and everything, and then becomes very, very disastrous. Some of the most disastrous floods in the US have resulted because of levees. Okay, so now with the alteration of rivers, and when hurricanes come and volumes of water are dropped down the sky, and then we have winds, we have tornadoes, we have all of that, rivers become powerful weapons. And we're talking of weapons in human terms because the river doesn't know it's a weapon. The river just knows that it has to get to the sea. It needs a passage, right? It's not human, it needs a passage, it has to get to the sea. So if we come with anthropocentric approaches, human-centered approaches, utilitarian approaches, what is the river for? And we don't think in ecocentric ways, thinking in terms of the ecosystem, thinking in terms of biocentric life forms. If we don't see the river as the river from ecocentric perspectives, then we will be in trouble. We will be fighting with a structure that is unpredictable, particularly when there are storms, hurricanes, typhoons, and things like that. So it's essential to think like a river. Why? We'll see. So let's look at this. Thinking like a river is a metaphorical concept that encourages us to adopt a more holistic and interconnected perspective of nature. Holistic perspective means we take the whole. You know, we don't reduce it to anthropogenic, but we take the whole. We take a system approach. We look at the whole river system, human, non-human. We look at the whole river system. Interconnected perspective. So we look at the connections, the interconnections on nature, life, and the world around us. It suggests that we should consider the characteristics and behavior of a river to gain insight. We consider the characteristics and the behavior of a river to gain insight into various aspects of its existence. Here are some key ideas associated with thinking like a river. Most of these ideas I had to think and bring them up. So some ideas of how can we think like rivers? How can we drop the anthropocentric approach, the human-centered approach, and adopt a more ecocentric approach that can lead us to living sustainably with rivers rather than living against rivers, rather than fighting rivers, fighting to control rivers and failing most of the time. Okay. So here, you can Google the Mississippi River and you'll find out how the Mississippi River has changed its course over the centuries. And this is due to siltation. And this is a map which someone traced, a hydrologist, a river hydrologist, to study how the Mississippi has changed its course. And you look at it, it's like a mess. And it's what people today will not allow because we think in linear senses. We think in terms of lines. You look at the way land was parceled out. If you're flying in a plane to the Midwest and you look down outside the plane, you're going to see the land looks like a checkerboard. It looks like a checkerboard, lines, bounding each other and little pieces. But then when the river comes, it doesn't follow those lines. So we think in diametrically opposite ways with the river. We think in terms of linear equations. The river does not think in terms of linear equations. When it comes against an obstacle, sediments, it changes course. When it comes against an obstacle, it changes course. And its goal is efficiency. The rivers tend to be very, very efficient. Over a time, a river can change its course in search for a more efficient path for water to flow from, for water to flow from headwaters to the sea. My image is blocking a word here. So as a river leaves the source, it has to get to the sea and it has to look for efficient paths to follow. And so when obstacles come, it has to look for an alternative. When obstacles come, it has to look for an alternative path. And that is nature. It is very natural. It is the nature of a river. And we must understand that if we block a river this way, it must look for another path. It must look for another path because the flow doesn't stop, right? We can't block it completely. The waters will pile up and it will either break that blockage or the river will flow to another path until a flood comes and then maybe it hits that blockage. And then the thing that lies beyond that blockage, it pays a price. And so rivers tend to be very, very efficient. It tends to be very, very efficient, right? Okay, so here, let's look at this river flowing from its source in the mountains to its outlet in the seas. And you see how it's winding. You see active point bar. That active point bar, it's where the river is creating, it's dropping sediments. Sediments are cropping up at that bar. The inactive bar, it's where there's already sediments. You have wind-blown sand, you could see. And so you see this bank, the river is eroding this bank to the right, where you have this tributary arroyo. This tributary arroyo meets the river. Where it meets the river, it comes with its own sediments. And then there's a bank to the right, which switches the river to the left. But because this river hits the bank, it's going to continuously erode this bank, right? And you see it switches to the left here, natural levees. There are natural levees here. But in the long run, this river, are we coming up or down? Yes, okay, we're going up the screen. So you see this river, you see Chute, right? The river cuts through Chute because as the river flows down, it's also eroding the right hand bank. It's eroding the right hand bank as it's going. But in the long run, this river is going to connect through chute because that's the most efficient, that's the easiest way. If the land there is vulnerable, it's going to connect straight through chute because it usually follows the low, it follows the path of least resistance. Rivers always search for the path of least resistance, right? And this should channel, this new channel, rivers do that most of the time. You know, particularly when they start reaching floodplains and they're meandering. Sometimes those meanders, very often those meanders, they straighten out because the river looks for the path, the path of least resistance, and it cuts through a field, and it drops off the left. It drops off this meander on the left where you have stable point bar, and it becomes an oxbow lake. So it becomes an oxbow lake, and the river has cut a new path leaving behind an oxbow lake. So you see the oxbow to the right. The oxbow to the right, as you move down this river, where it reaches the floodplain, you see the oxbow to the right. That's what I'm talking about. Okay. So here you actually see river processes, riverine processes on this page. How you look at these channels that join the river, the tributaries join the river, and then the river flows down. And why is it taking this sluggish path? It's because of sediments. The sediments are heavy, and the sediments are channeling the river left and right? Okay. Have you ever found yourself trying to get into someone's head, for example, someone you love? Here we are looking at the concept of thinking like a river. How to think like a river? How can we think like rivers? How can we get into the head of the river? So have you ever found yourself trying to get into someone's head, for example, someone you love? Children often try to get into their parents' heads for various reasons: to learn, to make sure they do the right thing at home, to enable them succeed in all they do, e.g. follow institutions correctly. We come back to institutions. We already examined the basic institutions and how they help us in constructing our views of reality, of material reality, our views of humanity, our views of conduct, our views. So children try to get into their parents' head for various reasons: to learn, to make sure they do the right thing at home, to enable them succeed in all they do, follow institutions correctly, to relate perfectly with their parents, and to succeed in life. We study the atmosphere, the river, space from the human perspective, but do we really try to think like these entities in the way they function? Do we really try to think like the atmosphere? If we think like the atmosphere, then we'll be very careful about pollution because it carries pollution everywhere. Then we think about the earth. And when we talk about the earth, we talk about ecological footprint. Ecological footprint is those are the footprints that we leave on earth. Like when we consume, when we cut down a forest, when we cut down a forest, when we cut down a field, those are ecological footprints. We're leaving footprints in ecosystems, so they call them ecological footprints. So we study the atmosphere, the earth, space from the human perspective. But do we really try to think like these entities in the ways they function? Thinking like them means understanding how they behave, the way they behave, what principle guides their actions, flows, movements, vibrations, and resistance. So learning to think like a river means understanding stream flows. You understand the flows of the stream or the river, understanding droughts, understanding floods. Thinking like wetlands means understanding what wetlands do, how they behave. Thinking like deltas, river mouths, where rivers enter the sea, trying to understand low and high tides. One of the things about wetlands is that wetlands have always been considered historically as dangerous places because generally wetlands were very, very fertile places with a lot of wildlife, like a supermarket in terms of fertility. And wetlands brought a lot of wildlife like alligators, crocodiles. And so humans grew up. There was a dread about wetlands up till the Industrial Revolution started. And when it started, humanity started draining wetlands. They saw wetlands as terrifying. Snakes lived, all sorts of snakes lived in wetlands, wild animals, and even wild people, people who had committed crimes in society. They went to wetlands because everyone was afraid of wetlands. And then with industrialization, um, particularly in Europe, they started draining wetlands, draining them and filling them up and occupying them, you know. And so it led to the death of wetlands. Most people, most societies in Europe, most communities and countries, they saw wetlands as uh, places that were full of miasma, smells coming out of the muck in wetlands, and smells, and so requiring wetlands to be drained and made civilized, to make them more civilized, you know. And so they didn't understand the perfect function of wetlands. That wetlands are the way wetlands are. They are very, very rich carbon sinks. You know, wetlands sink a lot of carbon dioxide from the air. Wetlands are breeding places for a lot of wildlife, a lot of animals, a lot of birds, snakes, all of their breeding places. In actual fact, wetlands are supermarkets. This view of wetlands only came about very, very late, I think about the 1970s, when people started advocating against the destruction of wetlands, you know, and here in the US, it's been a huge fight, an ongoing fight about regulating wetlands. The, uh, the organizations responsible for uh, regulating wetlands, they've been fighting a huge fight, you know, with farmers, a huge fight with land developers, a huge fight with industrialists that want to convert wetland. Take, for example, the wetlands in Worcester. Uh, Very often, businesses want to convert those wetlands into housing estates, right? And then the environmental, the EPA will start fighting against them, and FEMA, they will start fighting against these organizations, right? So, how do we think like wetlands? How do we understand wetlands? How do we drop the anthropocentric approach and we approach wetlands from an ecocentric and a biocentric? Bio, it's life, you know. Okay, so we look at what we know about rivers. As we discussed in class today, rivers have a source, very often up the mountains like springs. They go through highlands to lowlands, and then they get into the sea. And where they get into the sea is called an outlet, right? So they have an upper, middle, and lower terrains that they go through. And we talk of the source, the river mouth. We talk of gradient, that the river have to follow a particular gradient. They have to follow a particular gradient, that they don't have a choice. Boundary crossing, rivers are boundary crossers. So we talk of when they parcel out the land in little parcels and a river goes through, it does not respect those legal boundaries. Those are human boundaries. Those are human legal boundaries. Those are economic boundaries. Those are agricultural boundaries. Those have nothing to do with the river. The river does not know them. It's us humans coming with anthropogenic approaches. The river doesn't know those boundaries, so it crosses those boundaries. And we can also say that the hydrologic cycle, the water cycle, shows that water crosses boundaries. Water doesn't respect human boundaries. It crosses boundaries. It changes its form and it moves, you know, through landscape, goes back to the sky and falls back elsewhere, like rain, right, or mist or whatever. Persistence. So thinking like a river, we are going to like start looking at principles. What principles can we develop which demonstrate thinking like a river? And we say that rivers are persistent. Rivers are persistent. They have agency. Agency is power. They have power to enforce change, to bring about change. And that must make us to be cautious, to stand and be cautious about the way we approach rivers. From the 18th century, there's been a lot of interventions in the US to control rivers through dams, through ponds, through dams, through canals. Most of those canals and dams, they failed one way or the other along the way, because once there's a hurricane or a huge storm, the amount of water being dropped down from the skies, very often they break they break through those dams. Sometimes they break through those dams, you know. So and they do it because of persistence, because rivers can be persistent, and when the volume of water is very, very high, that's when that persistence becomes dangerous. A river cuts through rock not because of its power, but because of its persistence. If you could follow rocks from the mountains to the sea, most of you have gone camping, you've gone on mountains, you've seen rivers, and you look at how those rivers have shaped those mountains, the way they shape those mountains, the rocks, cutting their path through those rocks over hundreds of years. So we call that persistence. A river cuts through rock not because of its power, but because of its persistence. And you can apply that to real life. People that are persistent often succeed, not because they're powerful, but because they're persistent, right? So if you have a problem with the assignment and you're persistent with me, you will succeed. You persist with me, you ask me questions, and you make your, until I explain everything to you, you will definitely succeed. And it's the same with academia and every persistence. A river cuts through rock not because of its power, but because of its persistence. So that would be the first rule which we should know when managing rivers, when governing rivers. Rivers persistently flow towards their destination, overcoming obstacles in their path. They exemplify resilience and determination in facing challenges. Resilience and determination in facing challenges, right? So we can learn a lot from rivers in terms of their persistence, their resilience, their determination, their ability to overcome obstacles, and their patience. We'll look at patience next. A river runs through the land. All these meanders, it's patience, finding ways to get to the sea, finding ways to get to the sea, right? Okay. A fundamental principle, rivers follow the path of least resistance due to gravity. This is very, very important for us to know. Water flows downhill along the easiest route. Rivers and water, they'll take the easiest route to flow downstream because they follow the gradient of the landscape. And sometimes they dig that gradient, they enhance the gradient to make their flow easier. They typically find and widen existing weaknesses. So they find and they widen existing weaknesses or channels in the land rather than carving through harder, more resistant material like bedrock. So when a river gets to a bedrock, it finds a way of either widening, or it widens existing weaknesses. It looks at weaknesses along that rock and it widens it, or it creates new channels in the land, right? This process creates the winding, meandering patterns of rivers because they have to follow the path of least resistance, the path that least resists them, and they're always in search of that path. Rivers are always in search. That's why you find that map of the Mississippi. It's like change is called so many times. It's always looking for because rivers flow constantly. Every second, the river is flowing. And so they are persistent in finding the path of least resistance. Our view of time and the river's view of time, we work on different time scales. Us and rivers work on different time scales. The river works on a far longer, far more patient time scale that could take it could take months, years, right? Many years, decades. River actions take a long time to happen. And sometimes when there's like a storm, a river can change its course at short notice. When there's a very, very huge storm, it can force the river to change its course at very, very short notice. Okay, so that process creates the winding, meandering patterns of rivers. Okay. So I'm tired. It's been a long day. So, okay. Surrender. Rivers surrender to gravity. Imagine that imagine you throw something up from a plane in the skies, right? There's no way it can resist gravity. It has to go down. So the same with rivers. So they surrender to gravity. They allow themselves to flow downhill. They let go. This teaches the value of letting go of control and allowing life forms to unfold naturally. So it teaches us the value of letting go control of rivers. Instead of us controlling rivers, we allow the river to unfold, right? And we adapt to the river. In that way, we make the river less dangerous to us. Okay, so adaptability. Rivers are constantly changing, adjusting to the conditions of the environment. Rivers are constantly changing, they're constantly changing because they flow every second. If you drop a leaf now, if that river guides that leaf and you follow that leaf, the leaf will take you right to the Mississippi, to the ocean. And so rivers are constantly changing. As they meet obstacles, they change. As they drop sediment here and sediment blocks these banks, they move to the other bank. They change their course to avoid those sediments. Wetlands are generally built by sediments. Most wetlands are built by sediments that the rivers carry from inland. And that's why wetlands are very, very coastal wetlands and deltas. They are very rich because of those sediments coming in from inland. You know, there are sediments that rivers carry, and they bring in a lot of biota or biological life forms, biota, in the wetlands. Wetlands has extremely. I did my PhD on wetlands in the Atchafalaya in Louisiana, South Central Louisiana, and also on the eastern side of South Africa. I was very fascinated by wetlands, though I ended up with butterfly conservation. So adaptability is one of the principles of rivers. Rivers adapt themselves depending on the landscape, not only the landscape, but also the amount of silt that they carry, right? Interconnectedness. Rivers are a part of larger ecosystems. Don't forget this. Rivers are a part of larger ecosystems, and their health depends on the health of the surrounding environment. If you have these farmyards along these rivers, if they drain this river, the river's health will decline. If they plant trees along the banks of this river, those trees will increase the health of this river in terms of organisms in the water that filter the water, organisms that eat up the debris in the water. Bacteria eats up the debris, converts the debris, and so enables the river to flow down without sediments piling up. So you have a lot of these bacteria and insects that eat up a lot of debris in river, enabling enabling continuous flow of the river. So rivers are interconnected with their adjacent landscapes. I use this word adjacent, direct, deliberately adjacent landscape. The relationship between the adjacent landscape and the river is very, very important for river health and for river flow, right? If there's a lot of erosion, if there's a lot of irrigation of this adjacent landscape, these farms, a lot of irrigation, right? A lot of clearing of trees, it's going to produce a lot of siltation and erosion of the river banks and sedimentation. And that sedimentation is going to lead to flooding because it's going to pile up and then create instances of flooding. So rivers are part of larger ecosystems. So we talk about the ecosystem of the river and the ecosystems on the banks of the river and the ecosystem where the river took its origin, right? And the ecosystem also in the delta where the river gets into the sea. So these are interconnections. They're interconnected. They are not separate. You cannot separate the river, the river at the delta where it gets into the sea. You cannot separate it from the mountain where it takes its rise. You cannot separate the lands adjacent the river on both banks of the river, following the river right through. You cannot separate the health, the ecological health of those banks with the ecological health of the river. So take note of that. Thinking like a river encourages recognizing the interconnectedness of all living things, all living beings and their environment. We're talking of the living things on the banks of the river, at the beginning of the river, at the end of the river, and inside the river. They're all interconnected. If you destroy one species, it's going to throw that. If you eliminate one species, it's going to throw that ecosystem in disarray. So, okay, interdependency. Another characteristic of river, another principle is that river health depends on the health of its riparian zones. Riparian zones, these are the zones adjacent to the river or adjacent terrain. Yeah, we did mention adjacent terrain. And it's also the region known as the watershed. So the watershed is those areas alongside a river. They are part of the river's watershed. And why? Because these watersheds, they feed the river. They have tributaries and streams that feed the river. And so they enable that river to continuously flow to the sea. The farmyards, if they produce too much sedimentation, then that river will become sluggish, right? So river health is interdependent with the health. The river ecosystem is interconnected with the broader ecosystem, and the river health is interdependent, right, with the health of the riparian zone. The riparian zone is the zone along the banks of a river. You can call it the adjacent terrain. In geography, we call it adjacent terrain. In biology and environment, we call it the riparian zone. We also call it in hydrology, we call it the watershed. Hydrology, we call it the watershed. Okay, so let's look at ethics. Now, how do we relate with rivers? Aldo Leopold appears in chapter, I think chapter 4, ethics in environment and society. There's one group is going to present on that chapter. I think the chapter on ethics, Aldo Leopold appears there very strongly. We talk of Rachel Carson as being one of the preeminent environmentalists in the U.S., environmental writers. We also talk of Aldo Leopold, who brought in the idea of ecocentrism and biocentrism. It's Aldo Leopold. And Aldo Leopold, I think he completed school from Madison or Yale? And he went and lived in a hut, in a small wooden structure in California, up north of San Francisco. What's the name of that place? That park again? He was studying the environment. He spent his whole time studying the environment and working with forestry. And from his studies, he brought up this idea of a land ethic. He was very, very focused on human environmental relations and creating better environments for future generations. So he brought up the idea of a land ethic. I did mention the wolf, where he looked into the eyes of the wolf that was shot and he saw beauty, and he said it would be tragic to kill these wolves because the wolves exist with a purpose. If the wolves eat the sheep, if the wolves eat the deer, it's because they have to balance the deer population. Otherwise, the deers would explode, right? The deer population would explode. And if the deer population explodes, then it could lead to wanton killing. So why wanton killing if the wolves could reduce that population and keep the ecosystem in a state of balance? If the deer or the bisons or whatever, if the population explodes, it's going to lead to overgrazing. Overgrazing could lead to drought, right? So there has to be a balance. So we have this chain reaction. This feeding chain, and we have this chain reaction that occurs. If there is no balance, there will be a chain reaction, a cascade effect on the landscape. So killing at the time, foxes were being slaughtered across the U.S. Even the mountain lion, the U.S. mountain lion, was almost killed to extinction. Even the bisons were slaughtered. So they were seen through the eyes of hostility rather than a system approach that saw them as playing a role in the system. When they graze, they also feed other animals. They grazed, so they also feed other animals. So they help to create a balance. And so Aldo Leopold said, a thing is right when it tends to preserve the integrity, stability, and beauty of the biotic community. A thing is right when it tends to preserve the integrity, like keeping the wolves alive. That's keeping the integrity of the biotic community, the stability of the biotic community, and the beauty of the biotic. Bio is life, so the biotic is the life community. So a thing is right when it preserves the integrity, stability, and beauty of this community. It is wrong when it goes against the integrity, when it destabilizes, when it destroys the beauty of that biotic community, it is wrong. So we're in the realm of ethics. Ethics is a field. It's a field of study now. There's specialists in ethics that do their PhD in ethics. Ethics is also a course. It's a course taught on its own, and it's also a part of the environmental course. And you have ethics on almost every field now. You have environmental ethics. I don't know if one course that if it's being offered here. The idea suggests that ethical behavior in relation to the environment involves actions that maintain the health and interconnectedness of ecosystems. It implies a shift from a human-centered view to one that considers the well-being of the entire ecological community. So this land ethic, which Aldo Leopold brought about, has been very, very critical. It brought about this land ethic. How must we relate to the land? Should we consider the land as a non-living entity or as a living entity? How do we relate to the wildlife around us? The birds, the forests. How do we relate to land? He saw it as a moral obligation that we are morally obliged, to relate to all these entities in a way that preserves the integrity, the stability, and the beauty of the biotic community. And he also brought about the biocentric approach, that every living entity has a value in itself. It doesn't have to be human-centered. It doesn't have to be utilitarian. What is its use? It has a value in itself. This little butterfly has a value in itself. But you know that butterflies help in pollination. We're going to come to that when we're going around in the school. I wanted to show you plants that pollinate, aesthetic plants. Most of the plants at school, you're not going to see many butterflies at school here because we haven't planted plants that, we do have plants that pollinate at school, but we don't have host plants. If we need butterflies at school, we need both host plants where they lay eggs for their children and nectar plants where the adult butterflies eat. Caterpillars mostly, they don't eat nectar. Caterpillars don't eat nectar. They eat mostly the leaves of plants. And butterflies lay their eggs. So very often butterflies, the caterpillars eat the leaves and the butterflies live on nectar. So now those two must be present. If you want butterflies to be present, you must create trees. And you know that butterflies, we saw the milkweed. I did show you the milkweed. The monarch only lives on the milkweed. Only the monarch butterfly it lays its eggs on the milkweed. The caterpillars eat the milkweed. The monarch gets the nectar from the milkweed, but it also gets nectar from other plants. The monarch also gets nectar, but mostly from the milkweed. But the caterpillar of the monarch only eats the leaves of the monarch. If there's no monarch tree, that caterpillar if there's no milkweed, the caterpillars would die. So now, if you want lots of butterflies to come, so you don't only need nectar trees, but you also need host plants where the butterfly will lay its eggs. And not only one species of butterfly, but you have to get now host plants for all other butterflies and also nectar. So the more diversity you have, then you're going to get 5, 10, 15 butterflies in their garden, 20. But that's going to take like years for you to start getting it's going to take years of planting those varieties of trees and letting them come up to before. So that's when you start talking of the integrity, the stability, and the beauty of the biotic community. We don't have those butterflies here, not many of them on campus, because we have destabilized the integrity, the stability, and the beauty of the biotic community here. We have nectar plants, but we don't have host plants where they can lay their eggs. So, okay. The idea suggests that ethical behavior in relation to the environment involves action that maintain the health of that environment, the interconnectedness of ecosystems, the health of that environment, not only for us, but also for the non-humans living there, like the squirrels, the rabbits, the butterflies, dragonflies, ladybug beetles, all those, ethical behavior. So we actions that maintain the health and interconnectedness of ecosystems, not just for us, but also for the birds, the mourning doves, all those variety of birds that come in. It implies a shift from human-centered view to one that considers the well-being of the entire ecological community. That's probably demanding, okay? And then thinking like a river means to move with gravity, not against it. To be ready to braid, to meander, to refuse straight lines, to carve stones, rocks, mountains, not with force, but with patience and persistence, to follow the path of least resistance, to carry what is given, leaves, sealed, bodies, stories, and to deliver them somewhere else, to know that upstream and downstream are never separate, but interconnected. Both are one thought unfolding, one thought that is unfolding. To see the rain, underground water or surface waters, rivers, streams, lakes, and the ocean as part of the hydrologic cycle, as part of a system. To understand that the river's mouth and outlet is not an end, but a widening into another body, a widening into the hydrologic cycle. You could actually continue many of these principles. These are just the ones that are brought up, but we can continue many of them and devise. And when you apply this to life, to our personal lives, it's almost, you see that it's also true. You move with gravity, not against. Once you start moving against gravity, it's like you're driving against the wind. You're driving into the wind. You will get more resistance. You will get exhausted, right? So instead, find a way of riding with the wind. When you sail, that's what we do, right? When you sail, when you parachute, you try to go with the wind. To be ready to braid, to meander, to refuse straight lines. Straight lines could be very, very risky. If you straighten a river, that's a problem. What do you do with sediments? The river would flow straight into the sea, and it's going to be when it floods anything in its path, it becomes very, very dangerous. It will erode the banks very, very rapidly. It will keep widening and eroding the banks because it has to carry the sediment. But rivers have to build landscapes as they flow along. So it builds landscapes with those sediments. It drops those sediments. Agriculture needs those sediments. Agriculture thrives when it has sediments. So the river has to spread those sediments. As it meanders, it drops sediments on this bank. It drops sediments there. It drops sediments there. It drops sediments there. And those sediments are good for agriculture. They're really, really good for agriculture. You won't need fertilizers if you've got great sediments. But if the farms are using fertilizers and chemicals, then the river is going to carry sediments with fertilizers and chemicals along. If the cities pollute the river, they drop dead cars along the banks of the river. They drop waste along the river. The river is going to carry that waste along. And when it reaches a bridge, and that bridge is low-hanging bridge, that waste will pile. It will pile on that bridge. It will pile up on that bridge. And finally, when the river, it floods and it reaches a certain level and breaks that bridge, it's going to take all that mess down. And the next settlement, it's going to, like a railway, it's going like a train, a massive, gigantic train driving through a city. And that's what you see when you think of these hurricanes. So, thinking like a river continued, change is the essence of flow. The river holds contradictions all in one hand. When you look at the river, there's contradictions like humans see destruction and renewal, violence and nurture all in one movement. We see destruction and renewal, violence and nurture all in one. But these are human terms. The river doesn't see it that way. For the river, it is balance. Balance is most important for a river. When a river floods, it's because a river is looking for balance. When a river changes its channels in the landscape, meanders left and right, it's because it's looking for the path of least resistance to the sea. But in so doing, it also drops sediments, which are good for agriculture. Okay, to take the shape of what holds you, we said that water takes the shape of its vessel. A river takes the shape of the landscape, right? When it meanders like that, it's taking the shape of the landscape. It's looking for the path of least resistance. A river speaks in a language without words. We've heard how silent a river is. Up mountain, it's rippling, it's sinking. It's the shape of the landscape. It's the geology of the landscape that enables that singing. So we look at these interconnections. Once we understand the landscape through which a river flows, and we understand thinking like a river, the behavior of a river, the interconnectors of, when we understand these bits and pieces and all of that, then we can create sustainable relations with rivers. Our cities can then live sustainable, our farms, villages. If we have to manage these rivers across the country, with this understanding, we'll be able to create sustainable systems. And now we're talking of climate change, right? We're talking of climate change with the huge masses of water being dropped from the sky in particular places, and that impacts on rivers. And then rivers impact on the farmlands and on the cities. So we need to think more seriously about how we relate to rivers, to ecosystems, and to the changing weather patterns and precipitation, that's rainfall, melting glaciers. We need to rethink those systems. We need to think like the ecosystem itself, beginning from rivers. We need to think like the air. How does the air function? If we understand the way air functions, the demands of air, we'll better be able to work along with it. And so thinking like a river could lead us to also understand, how do we think like the air? How do we think like land in itself? How do we take care of the land? So Aldo Leopold brought up the idea of the the land ethic. But of recent, philosophers have been working on this water ethic, the water ethics. They worked on water ethics for the past 10 years. But increasingly, people like myself were also thinking of river ethics, because of the flooding now, the necessity of rivers, the meaning of rivers, not just the uses, but the meanings of rivers, the ecological value and significance of rivers and ponds, and how they're related to ponds, to lakes, to the ocean, to the hydrologic cycle. We have to think like rivers. Flow. Rivers have continuous flow, symbolizing the importance of going with the flow of life rather than resisting it. It teaches us to accept change and to embrace the natural progression of events. Rivers both erode and create land. This duality emphasizes the idea that destruction and creation are often intertwined. So here, look at this diagram carefully. And I did talk about the highway. When you're driving and you're turning a corner, where is the tension and the danger greatest? When you are turning a corner? And you look at the map of the camp in Guadeloupe, the camp in Hill Country, along the Guadeloupe River. Look at the map and the river. When you pay attention to those maps about the river, where the camps and the buildings were situated along the river, there's a river there and a channel. I think I'm going to make a video on that. Renewal. Rivers constantly renew themselves as freshwater flows in and out. Thinking like a river encourages us to embrace the idea of renewal and growth. It encourages us not to get stuck in a rut. So if you get stuck in your assignment, reach out to me, so that I renew you, because I know once you start thinking, you might get stuck. Nourishment. Rivers provide water and sustenance to countless communities and ecosystems. Thinking like a river reminds us of the importance of nurturing and supporting others and ecosystem. Supporting others, nurture, support others and ecosystems. And it's also in the classroom. We must nurture, we must support others in the classroom. We must do the same with ecosystems at school. We haven't looked at the ecosystems at school, but there's a fascinating ecosystems here at school. You don't know, the wildcats used to live at school here. And raccoons, a few years ago, there was an epidemic, a disease killed of raccoons. And so we have a lot more bunnies now than before. And you will not understand until you start walking at night and exploring. Then you're going to, and then asking people about those things. Then they'll tell you about the ecosystems here. Okay. So here, environmental flows, thinking like a river is a metaphorical tool to help us develop a more harmonious and mindful perspective on life. Harmonious, mindful, interconnected, interdependent. It encourages us to embrace change, interconnectedness, renewal, and the natural rhythms of existence, ultimately promoting a sense and balance a sense of balance and well-being. Okay, so now this is my introduction to you about river. I've not gone into a lot of the like the geomorphology. We've talked a bit about the geomorphology, the geology of a river from the mountains, cutting through rocks, path of least resistance. With morphology is like the form of the landscape, cutting its way through. So that's the geomorphology of the river. And hydraulics, you talk of hydraulics when it's turning a corner, and then going down a gradient, turning a corner. Those are the hydraulics. All those meanders we're dealing with hydraulics. We did mention stream flows in class. I'm not sure you'll be reading all of that in the news articles that you'll be reading for your assignments. I'm not sure you'll be getting all those terms, but I want you to get all those terms because you can easily apply them to those articles. You can apply them to those articles, and that way you get into seeing the river as a system in very, very critical language. I'll make another video again to help you because it's 60 now. It will be too heavy to transport this, to convert this. Okay, class, I hope this gives you a good introduction to river systems. I want you to be able to, when you pick up a book about rivers, you should enjoy that book. When you pick up a book about rivers, you should enjoy that book because a river is like life itself, our own lives that flow. The flow, not just your individual life, from birth till when you are 90, 100, but all our lives flowing in time and space. Because even at here, WPI, our lives flow together. Our lives flow together. So we are like a river. We are like following a river in time and space. And so we have to understand these principles of mutuality, interconnectedness, understanding the system, how the flows, and when we understand that system, life is much better. If we instead take a disconnected system, separation, disconnection, anthropocentric, entirely anthropocentric, self-centered, that's when destruction really comes. That's when we get these floods that nobody gets saved, right? So thinking in terms of rivers, it's a very beautiful, it's not just scientific, it brings in almost every discipline: biology, geology, geography, physics of water flows, the chemistry of water, siltation, all the chemicals that go into water, from the farms and everything, siltation, lightning with sulfur, thunder sound, everything comes. And you also look at floods. When floods destroy cities, it's not just lives, it's also economics. It also tears the landscape, it destroys bridges, everything, and so and then recovery programs mean every discipline has to get involved in recovery programs. So I will end there and then allow you time to go through those questions, to go through your research questions, and then I'll be responding as you have. If you have any issues, just let me know. We'll have Zoom chats, group by group. We'll have Zoom chats if possible. And then I'll be responding to your questions, and I'll make another video on rites of passage and another one again. As soon as I read your questions, I'll make another video to help you. But use this now, go online digitally, start looking for articles on that flood, and start seeing the explanations. You'll be seeing the explanations, you'll be seeing the controversies, you'll be seeing all of that coming up. I might give you some articles on rivers, about 1 or 2 or 3, which could help you with that assignment. As soon as you do the first draft, let me have the first draft anytime between now and the 7th. Let me read the first draft, and then I would make comments and give you, and then you polish the final draft. Then you submit it 14th, or I could stretch it. We submit it by the 14th, or a little after, but at the most the 21st, so that that will be your midterm grade. I think that's all for today. It's 64 now. It's very, very heavy. I would stop here and try to convert it and send it to you before you head off for your long weekend tomorrow. Okay, stay blessed, all of you. And one thing, I did solve that problem with technology. I went to the technology office After that, I wasn't happy. You could see that I wasn't happy. So I went there and they solved it. So it's solved now. From the next class, we're not going to have any. We're not going to have any issues with technology. I'll use my computer straight. I'll just plug it in, use an HDMI cable, and everything will just go straight. And you can also use, when you're presenting, just bring everything in your computer. You just slot that HDMI cable on your computer and you present straight. We usually had problems with presentations, with student presentations, but I think I would just check those cables to make sure that as soon as you come, you just slot that cable on your computer and it goes straight to the whiteboard. Okay, have a wonderful weekend. Mail me. Don't sweat it out. If you find yourself sweating out over a question, know that there's mail me, email me. Let's have a Zoom chat and let's find the easiest way, the path of least resistance, like a river flowing to the sea, right? The path of least resistance. That's what you should do. Let's find the path of least resistance, so you get to the sea, and then rise. You rise like water vapor. You get to the sea, you rise. Okay, good. I'll see you all. God bless you.